To do incremental visual tracking using principal component analysis, what we want to do is we want to build a tracker that's not just based upon a single patch, but sort of constantly updates some form of a model. And between me and you, that model is going to be a basis set. So we're going to keep changing the basis set a little bit as the model moves. We want something that runs quickly and can operate even if the camera's moving. And of course, the general challenge here is we would like this thing to be able to handle if the pose is changing, so how the thing is moving, rotating, translating. Maybe parts of it get occluded. Okay, and we'll talk about how to handle occlusion in just a bit. You have illumination change, and you want to avoid drift. That is, you don't want to start tracking someone's face, and all of a sudden you realize you're just tracking the bottom half of their face, and then it just gets stuck on a file cabinet. Right? You want to stick to their face. So the paper that some of this is pulled from is this Incremental Learning for Robust Visual Tracking. And I'm just using this, I mean, it's at this point known well, and also it gives you a sense of how to use principal component analysis, which we just learned, particle filtering, which you know, in order to do incremental tracking. This doesn't really belong in the recognition unit, but since we couldn't do it until you knew about PCA, here it is. So here are the main ideas, all right? First, we are going to use some form of a particle filter, but the particle are going to represent the deformation. And the deformation may mean just an affine, that is 6 degrees of freedom. It could be similarity. It could even be just translation. But the idea is that the particles are going to capture how the geometry changes from frame to frame. The second main idea is that we're going to use the subspace method that I talked before about detection. Right? So the idea is we have some small set of eigenvectors. They can reproduce only images that kind of look like something that comes from this class, and we're going to use that subspace in order to say, aha, that's a good example of the thing I'm tracking because I can reconstruct that image really well. The third thing, which is kind of the new and cool part, is that we don't fix the subspace. We let it change incrementally as we get new. So we track this image. We track this object, we bring in the new image, and we might say, oh, maybe it's changed a little bit. Let me change my subspace just a little bit. So by changing my subspace a little bit, I can track changes in appearance, but because it's an entire subspace, I don't get fooled by a sort of a small variation that's just local in time, and I can sort of hang on to the object. You'll see an example of that as we go forward.